Hello everybody, hope everybody is doing great. CRS here. I am back with another video. Today we will look at how to solve problems with vectors and resultant of vectors using graphical method. In one of the previous videos, we have looked at how to get the expression for resultant's magnitude and the direction of the resultant. We'll apply that today. Let's start with the first question. It's quite an interesting question and is asked quite a lot of places. Let's begin with the question. A, B, C, D, E, F is a regular hexagon with point O as the center. So here is a hexagon and point O is the center. The value of AB plus AC plus AD plus AE plus AF. So you need to add vector AB, vector AC, vector AD, vector AE and vector AF. Let's see how to do that. So here I have a hexagon. That's now we shall mark all the vectors for that matter. Let's begin with this exercise. We have vector AB. So let me mark vector AB. So vector AB starts off like this, and that's vector AB. Let's talk about vector AC. Vector AC is this. That's vector AC. Vector AD is starting from A, that is vector AD. AE is starting from here, that vector is AE, and AF is starting from here, this vector is AF. Now we have to find the sum of all of these things. So you might wonder how to calculate, because we only know the formula for calculation of resultant of only two vectors. There are quite a few vectors here. There are about 5 vectors here. So how do you calculate the resultant? The solution lies in very simple logic, and it's very simple, very enjoyable. So let's look at it. Let's imagine that I draw vectors to point B, C, D, E, F from the center O. There you go. So this is a vector, that is a vector, that is a vector, that is a vector, and that is a vector. So from the center I have drawn these vectors. I can also just mark it with a white color pen, so something like this, to these points from O, from all points except A, because we just have to sum AB plus AC. So I have done this. The purpose of doing this particular job, which is starting from O, we draw a vector to B, from O to C, from O to D, and so on, is because we will be able to employ triangle law of vector addition with ease. Watch, it's fantastic. Now if you want to get vector AB, you can write it as AO plus OB, because AO plus OB, my dear friends, AO plus OB is AB. Similarly, AO plus OC is AC. AO plus OD is AD, and AO plus OE is AE, and so on. Similarly, lastly, we have AF being equal to AO plus OF. We can just write all of these vectors like this. We have vectors AB, then we have vectors AC, AD, AE, and AF. All of these vectors can now be written as AO, vector AO plus OB, and AO plus OC, AO plus OD, AO plus OE, and AO plus OF. So these are the vectors. We got to sum all of these. If you sum all of this, you will get AB, vector AB, plus vector AC, plus vector AD, plus vector AE, plus vector AF on the left hand side. On the right hand side, let's find out what happens. AO plus AO plus AO plus AO plus AO is 5 times AO. You get that. But there is something very interesting happening out here. Please watch. We have OB, my dear friends, and then we have OE. Let's look at this. OB and OE are equal in magnitude but opposite in direction. So they would get cancelled. And similarly, if you just look at OC and OF, OC is in that direction and OF is in this direction, these two vectors would get cancelled. When that happens, you will have OB cancelling with OE and OC cancelling with OF. You will be remaining with OD. But you know what? OD is a vector as long as AO, and it's also in the same direction as AO. If there are two vectors, in this case OD and AO, which are equal in magnitude and same in direction, they are two indistinguishable vectors. So instead of OD, you can write AO once again, plus AO, my dear friends, plus AO. So it totally becomes 6 times AO. 6 times AO is option C. That's how you get to the answer. It's as simple as that. This is how you use triangle law of vector addition in order to get to answers. This is an idea that you can always use to get to answers with absolute simplicity. Let's look at another question based on calculation of magnitude. It's an interesting question. Let's go further. Here we have a car traveling 6 kilometers towards the north at an angle of 45 degrees to the east. Let me imagine the situation. We have the directions now. Let me draw the directions. So this, my dear friends, is, let's say, the east direction, and this direction is the north direction. Maybe you might want me to write it. That's east and this is north. Well, we have a displacement, a car traveling from the origin, let us say, and it travels to a distance of 6 kilometers at an angle of 45 degrees. So this angle happens to be 45 degree. I'll just make this look a little bigger and better. Well, this is a vector. You can call that the 6 kilometer vector. That's the 6 kilometer vector. Let's also read the question further. And then travels a distance of 4 kilometers towards the north at an angle of 135 degree to the east. So my dear friends, that is east. This is 90 degree. 90 plus 45 makes it 135. So let us pick up another vector that can be denoted like this. So here is a vector which makes an angle of 135 degree with the east direction, right? Let me basically assume, okay, so here it is, the vector. This is the 4 kilometer vector. That's the 4 kilometer vector. And it's at an angle of 135 degree with the eastward direction, 135 degree with the eastward direction. So we understand the question well. From the starting point, what does the angle, what angle does the straight line joining from the initial and final point position makes with the east direction? So we have to calculate the angle that the resultant vector makes. So the resultant is quite easy to get. Watch. So let's assume that this is a starting point. That is certainly the starting point, and this is where the car has gone to. This is the initial point. That's the final point after going all that to all that place. Let me mark the resultant, make it bigger. So this is your situation depicted graphically. Now I've told you that you can play around with vectors. Don't change their magnitude or direction. Don't change their magnitude or direction. You can simply move them. You can simply move them as long as you don't change their magnitude or direction. So I've just done that. You can mark the angles now. This whole angle happens to be 135 degree, and this is a 4 kilometer long vector. So the resultant of these two, my dear friends, is this vector. Let me call that vector D because that's a displacement. Okay. We need to find this angle, which is the angle made by the resultant with the eastward direction. Let me call that angle, let's say, beta. Okay, let me call that angle beta. The angle between these two vectors is 90 degree because this is 45 and you add another 90 degree, that's when it becomes 135. So the angle between 4 kilometer vector and the 6 kilometer vector is 90 degree. Let us find the magnitude, because in the options, how far the question is, that means you need to calculate the magnitude of displacement, and what angle, that means you need to also calculate the direction. You have to calculate the magnitude of vector D and the angle beta. because the question says what angle does the straight line joining the initial and final points make with the east. So that's east, and beta is what we have to find out. If the question is clear, we can go ahead and solve the question. It's not going to be very hard. So let's find out. The resultant vector, my dear friends, is calculated as root of a square. Let me write this as a square plus b square plus 2 times ab cos theta, theta being the angle between the two vectors. Let me call the 6 kilometer vector vector A and 4 kilometer vector B, right? The directions have also been shown in the graph, so we are comfortable writing it that way. Let me substitute, my dear friends. R would simply be equal to root of a square plus b square plus 2ab cos theta. Theta is the angle between vector A and vector B. It's 90 degree. Cos 90 is 0. So you don't have to worry about this term. This term goes to 0. All you have is root of a square plus b square. So we have R equal to root of a square. 6 square, my friends, is 36 and 4 square is 16. The answer is root of 52 kilometer. So root of 52 kilometer is option C and option D. One of these two is correct. We will have to figure out the angle it makes as well. Let me say that the resultant makes an angle alpha with one of the two vectors, in this case vector A. In the previous video, you might have seen how to calculate alpha. My dear friends, tan alpha is written as sin theta by cos theta. That's what I've taught you to do. Sin theta by cos theta. You write sin theta by cos theta, and you need to see whether to write A or B, because alpha, which is the angle made by the resultant with one of the two vectors, sticks to A. You will write B with sin and cos, and then there is a in the denominator. That's how you write the formula. Having shared that with you, you can calculate what is tan alpha now. Tan alpha, my dear friends, is B, which is 4. Sin 90, theta is the angle between the two vectors. So sin 90 it is, divided by, this is 4, and A is 6 plus 4 cos 90. Cos 90, my dear friends, is 0. So automatically this term goes to 0. All you have is 4 by 6. 4 by 6 is 2 by 3. This is tan alpha. This is tan alpha, right? What would alpha be? By implication, alpha would become equal to tan inverse of 2 by 3. Tan inverse of 2 by 3. Now, but that's not what we have to find. We have to find the angle made by this vector with the east direction, which is alpha plus 45. I have something very simple to do, because a little bit of math will enlighten our path. Let's try to do that, my dear friends. Tan inverse of x plus tan inverse of y is tan inverse of x plus y divided by 1 minus xy. This is something we know. If we know that, it's quite easy. Now you need to calculate the whole angle. So I might just write alpha is tan inverse of 2 by 3. We have tan inverse of 2 by 3 plus tan inverse of y. Y is tan inverse. I mean, you need to get 45 degree. Tan inverse of 1 is 45 degree. So you can just write 1 equal to tan inverse of x plus y. That's 2 by 3 plus 1 divided by 1 minus 2 by 3, because 1 minus 2 by 3 minus 1. This, my dear friends, will give you tan inverse of 5. So you will get tan inverse of 5. Now if you just see, we got the magnitude of the resultant 52, and we got the direction of resultant, which is tan inverse of 5 with the east direction, which simply means option C is the correct answer, right? Option C is the correct answer, and that's how you get to the answer. After this practice, I would like you to brainstorm about a question. So I've got a homework for you. Put your options that you get right in the comment box. So let's look at the question. Here is the question for you. Two vectors p plus q and p minus q, where p is perpendicular to q, when act at an angle theta 1 with each other, the magnitude of the resultant is 3 root of 3 p square plus q square. When they act at an angle theta 2, the magnitude becomes root of p root of 2 into p square plus q square. This is possible when? So we have the options here. It's quite a bit like assertion and reason question. It would be great if you can solve this, and I'd be glad to help. Comment in case you need help. But do remember, this was an exercise, but you need to understand the day you stop growing is the day you start decaying. Thank you so much.